Hi, Sophia. So in doing this problem here, what we have to realize is that when I multiply to get this, I end up multiplying this value times that, and this times that, and I add them together. So when I do it, I get 2 times the 1/2, which is those ones, plus the 4 times negative root 3 over 2. And so if I simplify this one, those cancel and I get 1. Those cancel here and I get 2, and it's minus 2 root 3. So this is the exact value of that first cell there. When I go to look at the second scenario, it's this one times that, and then 1/2 times 4. And so when I do that one, I end up being 2 times the root 3 over 2 plus the 4 times 1/2, 4 times 1/2, which gives me root 3 plus 2. And so here's the x value, here's the y value as a component as such. This is one number, and this is one number. All right. So now the second part, though, when I have matrices, let's say I have 5, 2 plus, let's say minus 1, 7. When I do that, I think you get 4 and 9. Okay. So what's happening on this problem here, when I'm coming along to multiply, or to add this and that one together, so what happens, it's 1 minus 2 root 3 plus 2. So when I add them, only those get added together, and so it ends up being 3 minus 2 root 3. This is exact value, hence I get this one there. When I do the same thing here with the 3 and this number, it's only the 3 and the 2 that actually come together to get 3 plus 5. Hopefully that answers your question. If you want more clarification, let me know.